Dinner. Hello, everyone. This is Shauna, and I'm coming to you today to clean up a question from last night. You may have noticed there was no recording. That's because my internet disconnected right when the recording was rendering and the recording was lost. So I'm trying to remedy that right now. But the question from the classroom was, how do I create a frequency distribution given some data? So I'm going to attempt to reconnect that for you right now. Let's start by going to the PowerPoint instructions. This is part of the PowerPoint for section 2.1. This is page 3 of the page 1 of the procedures for a grouped frequency distribution. So actually it says sort the data, find the highest and lowest values, find the range, select the number of classes that you desire that will be given to you, and then find the width by dividing the range by the number of classes and rounding up to the next whole number. Okay, so that's the procedure. I'm not going to show the calculator procedure in this video. I'm going to assume that you know how to put the numbers into your calculator and sort them, but I will show the steps from step 3 and on, which is what the student had asked for. So let me show you now. Let me change screen shares and show you the problem that we were actually looking at. This was a version of the problem that we were actually given. This is, if you have the textbook, this is section 2.1, number 17, page 52 if you have the physical text, page 77 if you're looking at the ebook text. This is differently numbered on your homework, but this is the problem about the plasma TVs. 40 plasma TVs were tested, and the number of watts per hour they were used while running for 4 hours a day was recorded. I skipped putting the data. You have the data in your homework page. You have the data in your textbook. Construct a frequency distribution for the data using 6 classes. So let me just pause here for a minute, and I'm going to stop sharing so I can pull up the homework page. Let's see. Which I thought I had, but I guess I don't. So let me look. Okay. Let me share screen one more time here. Share screen, oops, share screen. I'm not sharing screen. This is your homework for 2.1. And the data for the plasma TVs, this is number 9 on your homework. And here is the data that you were given. So what we're going to do is you're going to put this in your calculator. You're going to sort it. As I said, I'm not going to show that procedure in this video. But once you do that, you'll find that if you sort the data, you'll get a result that's similar to this. You'll find that the minimum is 465, and the maximum is 514. From that, we can find the range, which is found by taking the maximum and subtracting the minimum, and then dividing by the number of classes that we want. So 514 minus 465 gives us 49. If we divide that by 6, we get 8.166 and some change. If we round that, we remember we want to round this always to an odd number so that the midpoints come out as whole numbers. That's a little bit beyond the scope of this section, but you'll see in later sections why that becomes more convenient. So we round this to 9 here. Now, the question was, I had a couple of questions about this. One person said, how do I find the class limits from my distribution? Well, if you start at the minimum, which is 465, we know we're doing 6 classes. So if we take, let me share this on the whiteboard. If I take, remember that my class width is 9 units. So my minimum is 465, right? And my class width is 9 units. Okay, so what I'm going to do to find my class limits, is I'm going to start with my minimum, 465. And I'm going to add my width to it, 465 plus my width, which is 465 plus 9. If you add 465 plus 9, you get 474. Okay, that's 474. If you continue that, you keep adding. So you get 474 plus 9. That becomes 483. Okay. And you keep going until you have 483. You keep going until you have sufficient numbers. So when you do that like this, it looks something like this, 465. And the next number, remember, you're dropping down a row when you do that. So then you have 483. And then we have, I'm sorry, 474 before that. I'm sorry, I missed the number. 473. 484. And then you get 492. This is 483. I can't type today. This is 492. And I keep adding 9. I get 501. And I get 510. Now, the other question that somebody had is when I'm doing the upper limits. So here I'm going to take 1 off the successive higher limit, the lower limit, to get the higher limit. So this would be 472. Remember, these limits do not overlap. Okay, the limits do not overlap. So these should have a space, and they do. This is 482. This is 491. So this is going to be 491 here. This is going to be 500. And this is going to be 509. Now, you have an upper limit for the next class. So what some people do is they add, this is 400, you know what? This is 473. 473, and I made an error here. This is 474. Okay, now it should match. 483, 492, 5. Okay, so these should be 9 units apart. 465 to 474, and they are. 474 plus 9 is 483. 483 plus 9 is 492. 492 plus 9 is 501. 501 plus 9 is 510. Here on this side, you're doing the same thing, but all I did was take one away from each successive unit. You can do that here. Some people add an extra class down here initially, 519. You don't need that. It asks for 6 classes. But if you're using the subtract 1 from the next class, you're going to need 518 for that. Or you can just add 9, just like you did on the other side. 473 plus 9 is 482. 482 plus 9, 491. 491 plus 9, 500. 500 plus 9, 509. And 509 plus 9, 518. Again, we don't need this, so I'm going to get rid of that. This is our, these are our class limits, okay? These are our class limits here. So now, the other question that somebody had was, well, my data only goes, it doesn't go higher than 514. This is 518. Do I stop? No, you don't. Your limits have, your classes rather, have to have the same interval, the same width, regardless of where your data ends. It's a good thing if your upper class limit on your last class is a little bit beyond your maximum value. That means that you've been inclusive and you've included everything. If this last upper limit is ever lower than your maximum, you've done something wrong with the construction of your distribution, because you should be able to include all of the data, okay? So that's how you construct your class limits for this question. The class boundaries, these are the ones that overlap. So the class boundaries here, class boundaries are, you're going to drop a half a point from the lower and you're going to add a half a point to the upper one. So this is going to be 465 point, 465 minus 0.5, which is 464 and a half. And you're going to add to the other one, which is, this is 473 and a half. Okay. Now notice this starts at 474. We're going to subtract 0.5 from it. So we have 474 minus 0.5. That's going to give us 473 and a half. That's exactly where this other class ended. That's what it should be. These boundaries should overlap. The limits do not, but the boundaries do. So we continue. This is 482.5. Then we have 482.5 to 491.5. 491.5. Then we have 491.5 to 500.5. This is 500.5. And we continue 500.5 to 509.5. And then we have one more after this. Let me move this over so we're uniform here. And we have 509.5 to 518.5. Now you use the data that's in your calculator, your sorted data, to come up with the frequencies that fall in each one. So the frequency is actually coming from the counts on your calculator, okay? This is how many numbers from that list of data fall into each category, okay? Now, I did that before starting this video, so I can tell you that the frequencies are as follows: 9, then 7, 7, 6, 7, and 4. 6, oops. 6, 7, and 4. Okay. So there's my data. Now, it's always a good idea to add up your frequencies and make sure that they add up to the number of data values that are in your data set. So if you add 9 plus 7, you get 16. 16 plus 7 is 23. 23 plus 6 is 29. 29 plus 7 is 36. And 36 plus 4 is 40. There are 40 data points in your distribution. We need one more column for this distribution to be complete, and that is the cumulative frequency. Sometimes we abbreviate this as CF. So the first cumulative frequency will match the frequency that's in your first class. So you get a freebie here. This cumulative frequency, this first one, will match the frequency that's the first class here. So this is going to become 9, okay? Then what we do to get the next one is we add this 9 that we started with to the frequency below it. So you get 9, oops, plus 7 is 16. Okay. Then you take the answer that you got, 16, the cumulative frequency that you got, you add the cumulative frequency below that, which is 7. So we have 7 here, that's 23. It's 23. Then you take 23, you add 6 to that. You get 29. You add 29 plus the frequency below it. So you get 7 here. That's 36. And 36 plus 4 is 40. And your last cumulative frequency, if you do this correctly, your last cumulative frequency here, the cumulative frequency on the very last row, should match the cumulative, the total frequency rather, right here. You want the total of the frequencies to match the last cumulative frequency you have. It's not a foolproof plan that you've done this correctly, but it is one check that you can use to make sure that you've done the problem right. So your frequency distribution for the problem that I gave you, that was on your homework for the plasma TVs, should look like this. Okay, I hope that's helpful to you, and I will see you in my next video. Thank you very much, everyone. Take care. Bye for now.